Welcome to this talk. My name is Markus Neubauer. I'm working for a company called InsiderX, and in the next minutes I will present you our work towards trust in the complex cloud-based ERP systems by informing users about the system state. This work has been conducted together with Norbert Seif from the University of Applied Science in northwestern Switzerland. InsiderX, the company I'm working for, is a Microsoft partner company, and we are mainly selling, customizing and maintaining ERP software. In particular, Microsoft Dynamics 365 for finance and supply chain management, as well as sales, customer engagement, field service, and many more. ERP systems have changed in the last year, and for a few years ago, these systems were typically on-premise installations. This means sitting at the customer site or in a data center. But nowadays, almost all business applications, especially from Microsoft, are pushed to the cloud, or the new systems are cloud native. This means a challenge for companies like us and users of the systems, because nowadays business processes are implemented mainly by composing different cloud services, which themselves rely on multiple other cloud services and infrastructure services. However, for a regular user, it's all a web application, and he's using the web browser to access all these components and systems and does not have a clue about the system and the architecture underneath. But the situation is, if one of these components fails, if a service is degraded, the complete composition of services will be affected, and in such a situation it comes that the user is losing trust to the system because it doesn't understand what the reason is for this situation and why the system is not responding. So we came up with 3 research questions and goals we want to achieve an answer. And the first was how to use monitoring data to inform users about the system state. So this means what information can be used, monitored, aggregated in order to infer a system state and present it to the user. The second was to what extent visualization can help to understand the system state. Like I said, the systems nowadays are very complex and composed of many services, so it's a question how can we visualize such a situation in order to inform the user. And the third question is, does such a visualization help to improve the situation and help to improve the trust in software systems? In order to answer these questions, we came up with an approach called the Dynamic System Health Monitor. And this system is composed of 3 layers. The first layer on the left side here contains of different agents, and each of these agents is used to identify and retrieve information from a certain component. For example, this could be a local computer, and one agent is used to identify the CPU utilization and the RAM usage. Another agent may be used to identify the internet connectivity, download speed, upload speed. Another agent can be used to check the responsiveness of a cloud component, for example, log-on component, or perform a query against the cloud system. And we also foresee the option for manual input, so not only agent information, but also the IT department, the backend, should be able to provide some information. This information is centrally processed in the Dynamic System Health Monitor, and it uses a configuration database. The configuration database contains information about how to aggregate this information and how to derive a system state. So what is within a tolerance, what is a normal state, what would be exception, and how to handle it. And the third layer is the presentation layer, and we have decided to implement 3 ways to inform the user about the system state. The first is minimal intrusive by using an ambient light device. In our case, this is a mousepad with some LEDs, and we are using it to display the system status in form of a color-coded information. The second is a browser plugin, and because most commonly used browsers in our domain is Google Chrome, we decided to develop a Chrome plugin, and the Chrome plugin uses visualization like a traffic light. So green for everything is okay, yellow for there are some problems, and red we have problems that will break the component, will break the business process. And in a third way, we provide some more detailed status information and descriptions. So like said, we are using local computer information, connectivity, DNS information, upload download speed, cloud responsiveness, for example, the authentication requests, OData query, and also manual information. This is how the prototype looks like. We have implemented a Chrome plugin, that's what you see in the upper image. This plugin now presents system status yellow encoded, and the reason is that CRM system, which you see in the browser here, is facing some issues. In this situation, it is running an upgrade, and in the plugin details, you see some information provided by the IT department that says the CRM system is upgrading to a new version, and please be patient. The system response may be slow, but you can use the system. And in the picture below, you see the color-coded ambient light device. That's a mousepad, and this mousepad is also colored in yellow. This information also comes from the Dynamic System Health Monitor. In the first preview, we presented our prototype to the key users at a customer event from InsideX, and we got rather positive information and feedback. We also set up a lab with a lab PC and a mousepad and a ERP system in order to provide a sandbox, if you so want, where the key user could play around, set CPU utilization to high, disconnect from the internet, and to see how the system works and what the Dynamic System Health Monitor is displaying, and how the color is changing from green to yellow to red depending on what situation we had in this sandbox. We also got some feedbacks and some improvements that have to be done. For example, one was requested to give the user the ability to provide feedback. This means not only to be the passive user that gets information and color-coded system status, but also to proactive provide information and say, hey, IT department, we have a problem here, or I have a problem here in my system, please check this. In order to proceed with this research, we have planned to do an evaluation. In particular, this means to select some key users and evaluate the Dynamic System Health Monitor in order to see if this can increase trust if you use it. And the second question that we have to evaluate, if we are using the Dynamic System Health Monitor, does this have an effect on the IT support side? So by providing active live information to the user, does this decrease, for example, the number of support tickets? this concludes my talk on the Dynamic System Health Monitor. Thank you for watching, and I hope you enjoyed this short presentation.